Okay, I think we're about ready to get started. Did everybody see the trailer this morning? Quentin Clark's foundational session? That was like a sort of potted version of what we're going to see this afternoon. We're going to try and expand on that. In fact, this is the first of two sessions on the SQL Server developer tools, codenamed Juneau. We use SSDT for short. So when I say SSDT, that's what I'm referring to. So there's this session today, and then there's another one on Wednesday. We have a pointer ahead to that later in the deck. Okay, so we're here, I think we're all here gathered in this room today for the same reason, that ultimately database development is hard. It's very hard. It's too hard at times. And you've told us that, and we've set out to do something about that. And we think we've made some pretty radical strides with the tools we're going to show you today. My name is Bill Gibson. I'm a program manager on the team, responsible for developing the database development tools on this. And
my name is Mark Wilson-Thomas. I'm a program manager on the same team, and we hope you're going to have a great time listening today.
All right, so let's take a look at some of the things that you've told us are hard about database development. And let's leave aside the challenges of designing the database itself, the schema design, relational design, the intricacies of T-SQL as a language and performance tuning. All those are very hard too. But I'm really referring today to the development process itself, the way I create and change a database. And some things about it are particularly hard and make tool support a tremendous boon. So one of the sort of heart of this, or the root of many of the problems, is the notion of the database being stateful. When you run up an application, each time you run up an application, you get a shiny new copy of the application. But each time that shiny new copy of the application goes off to the database, it's the same old database with the same data in it. And at the end of the day, that need to preserve data and to preserve the schema over time, and this happens even when you start developing a database, just in your own test environment. You're forced to think not just about the design of the database, but about how you implement that design, how you get your idea into the database. So you find yourself writing author scripts almost immediately. The idea of writing a create statement seems like a luxury at times. And the dependencies, the database itself, the very nature of it, of SQL, is that the database is just stock full of dependencies between different kinds of schema objects. And that adds complexity and difficulty. Even the most simple changes can become quite complex. And we'll see an example of that in the demonstration in a moment. Errors are detected late, so that you find yourself, once you've worked out what these complex scripts are, you submit the script, and you find it doesn't run. And you get this feedback late. You get the feedback from the database when you try to submit it very often. And worse still, you may find that your script runs and executes, but you've actually left some dangling object, some dangling reference in the database, which is going to trip you up at runtime. So you have to test like crazy to get those out of there. So it should be better than that. And even when you think you understand what the database is, even you understand where you think you are, there's still the idea, and sort of seems crazy perhaps to someone who isn't in our profession, that the database has drifted. What a wonderful term. It's kind of moved the target. It wasn't where you left it when you last deployed the database. The DBA has come in, and for good reasons has had to patch or has tweaked the performance in some dimension. So it's not quite the way you expected it to be. And then the idea of working so extensively with change scripts often leaves you wondering, well, where is the definition of the database? So you can rely on it being in the database, but where is it from the standpoint of protecting and preserving that? If I wanted to go back in time and put together an app and the database that it was working with at that moment in time, it's very difficult to do that sometimes, to synchronize versions and version history. And if all that wasn't enough, now we have the challenges of targeting different editions, and most recently, of course, targeting SQL Azure, targeting database systems to the cloud, wanting to have the same database, perhaps, and run it in different locations. So we think there is a better way. I guess we wouldn't be here if we didn't think there was a better way of doing it. And if I said that the root of the problem was in the statefulness of the database, we believe that the heart of the solution is in the idea of working declaratively, not imperatively. So not working with scripts, but working with create statements, working with a declaration of what we believe the database to be. So you can focus on the design and let the tools look after writing those change scripts that are so hard to get right. We also believe it should be model-based design. And by model here, I mean a representation of the database. And you'll hear us talk about that a lot in this session. And this representation then is the same as the database. It's a representation in memory that we're going to build of the structure of the database. And because it's held inside the tools, inside the working environment, we can actually populate this either from the database itself or from a source code representation of the database. And once we build this model, we can then run tools over the top of the model. We can run validation over the model. We can check the model for consistency and completeness. But because we're running tools over a model that can be built from either a connected database or source code in a project, as you'll see, we can give you the same tools. The same tooling experience is now possible whether you're working directly hooked up to the database or off a project in Visual Studio. So that's huge. And if we're focusing on the schema itself as the definition of the database as the heart of the experience, then the idea of differencing between schemas, show me the difference between the model I'm working on and the database right now. That is it's the key, if you will, it's the sort of secret sauce in the product that we've built here, is this idea that we can produce a very fine-grained difference. We have an engine that does this. And it drives our deployment story. So you have this model you want to deploy. We look at the database. We compare the database and the model to the real database, calculate the difference, and use that to build the script. Use it for import. And we can difference between two projects. We can difference between two databases. We use it all the time. And you'll see sometimes we have a sort of an almost invisible head over that engine when we're doing publish, for example. But other times we have a very visual experience. Schema compare, we can show you at a fine grain the differences between these things. And because we're working with schema, we're creating a definition, we're emphasizing this idea of the definition of the database, we now have an artifact, the schema definition, or indeed a set of artifacts, that we can put into source control alongside an application. So now you can very precisely control the definition of a database, the definition of an application, and they can live together. And that's huge. And then finally, this idea that we want to be able to target different editions, different versions of SQL Server or SQL Azure. So one database project, one database definition then with a targeting switch. And you'll see us show that, how we can switch the target. Able to target different kinds of different installations of SQL Server. So that's database development in SSDT. Just remind ourselves what SSDT is. It's a little bigger than what I'm describing now. So this was announced at SQL Pass at the end of last year. And it's an umbrella. It's a packaging of what was the BIDS tools, so the analysis services, reporting services, and integration services on the right there, with what we're phrasing here, describing as a new service, the database services. But you will recognize much of what is here as was in the high-end database development tools in Visual Studio in the past. So we've really brought together now under the SQL Server umbrella all of the database development experience under one integrated experience, into one integrated experience. So it all runs in the same Visual Studio shell, and that's the most important thing. So there's no tabbing backwards and forwards between BIDS and the database development tools required. Now I can expand and blow out I could do this for each one of these chiclets here, these components of the SSDT, and I could spend probably a whole session on every one of those items there, but we're not going to do that. We're going to do a demonstration instead. It's much easier and much better to go and show you these things working than to talk about them. I'm going to call out just one item here because it's not in the demonstration, but it's quite an important item for us nonetheless. Bottom right, SQL CLR. There's significant improvements being made in the tools that improve the way and the support for SQL CLR. So if you want to see those, come along to our booth and we can demonstrate those to you. So I promised you demos and not talks. So that's what we're going to do pretty much the rest of the session now. It's going to be a long sort of arc. We can take one scenario and walk it through these various stages. First, we're going to do connected development. We'll tap up to the database and do some changes connected to the database. Then we'll take the database, import it into a project in Visual Studio, and we'll work offline, and we'll show you how that experience feels. Then we'll in fact, we'll then push that work back into the database, and you'll see how that works, how we're able to push the results of development back into a database. And then we'll publish to Azure, and that's kind of a cool part, and that's one of those God's willing moments in a demonstrator. So, you sort of keeps you up at night, that one. And then finally, we'll wrap up with a sort of, again, it's picking up this development process kind of theme here. We'll look at drift detection and snapshots. And I guess snapshots probably gives away the capability, the ability to lock down on a particular view of the development at a moment in time and difference, amongst other things, between those. So let's get started. Our first one is connected development. So let's switch into the tools.
Thank you, Bill.
OK. So the heart of the connected experience is our Server Explorer here on the left, to which we've added a new SQL Server node there, under which we can connect to any SQL Server instance or SQL Azure, as you'll see as we go through. And we can drill down into this, and you see a very familiar, if you're used to using SSMS, SQL Server Management Studio, you'll see a familiar connected Explorer here. So we can drill down and look at the various objects there. And the sort of heart of the connected experience, so I've talked a lot about declarative development, so I'm just going to sort of get this bit out of the way quickly here. We're going to go and take a look at a query window, first of all, and just demonstrate, of course, that we can run scripts and queries nonetheless, sort of like table stakes to get into the development tool space here. So we'll open up a query window, and Mark's just going to type in using that lovely star keyword there, select star, and you can see us getting great IntelliSense as we type here, just from the customer. There we go. And we can go execute this, and just as you expect, we get results back from the database. So nothing special there. And what we did as we started to expand that tree was, in fact, start to build that model of the database. It's a sort of lazy loading process. We begin to suck in things from the database that we're connected to. And we can make use of that. So as Mark moves across here, we can, for example, hover over that star there, and we get a tooltip, which is giving us some insight into the meaning of an asterisk here, which, of course, means everything for every column from this table. Now, it's not very, there's not much new there.
So we should do something a little more adventurous, Bill?
Yeah, let's do that. Let's go and take a look at what it would take to delete an object from the database. Now, you'll, I would expect, realize that deleting things from the database isn't very easy sometimes. You have to go chase down all the dependencies, remove all of those, and eventually you get to delete the object you set out to in the beginning. So let's go ahead and try and delete the customer table. Pretty radical thing to do in a database like this. We probably won't actually do it. But what we get here is this preview, and this is important to see. This is previewing what we would do if you hit the OK button, if we hit the Update Database button here, which we're not going to do, Mark, OK?
I sort of guessed we might not do that, Bill.
So the key thing is it's giving us a highlight of various situations here that exist. So we look at the bottom, first of all. We can see that this is what it's going to do. We're going to actually, just deleting this isn't enough. We have to drop some foreign keys, we have to drop a view and a table. So you don't have to do this. You don't have to, but it's warning me that if you want to delete this table, this is what we're going to do for you, to delete the table. It's also giving me information. We've got to go back up. The highlights section there, that's where I will be told that significant work was going to happen. For example, we're going to rebuild an index, rebuild a table, things that might take a long time, things that I might be concerned to know about before I set off a task like that. And right at the top, in fact, it's giving me a warning here about data loss. Well, there would be significant data loss if we were to go and do this. So,
yes, indeed.
So we won't do this. Let's cancel out of that. But that gives you a kind of feel for what's going on here in terms of tapping into this dependency information in the model to work out how to actually make a change. We'll see that again later. So now we're going to sort of spin up the arc of our demonstration. So we're going to do sort of make the justify the work that's going to be done here through this. So let's go and find everything from the customer view.
Yeah, I think we should take a look at the designer for this customer table.
No, we're going to go and take, before we do that.
Yes.
So let's go select everything from a view. It's a custom order summary view. And this view gives me a summary of the orders per customer. But it also contains some information. Here we go. Do you want to close this properties? So this contains a summary of order information. But on the far right-hand side, so this is order totals for each customer. We're going to come back to this view a few times. On the far right-hand side, if you perhaps stretch it up here a bit, we can see there's this ranking column. Now this ranking column, oh my goodness, the marketing team asked us to put this in some time ago. It was for them to, some lightweight mechanism for those guys to classify customers. It's proven very unsuccessful. You can see they've used no consistent ranking scheme, and half of the items haven't been ranked at all. So they've come back and they've asked us to improve this. So they sent us a spec.
Oh, yes, I think we have that spec somewhere.
Fully detailed spec.
It's very detailed.
Yeah, it's, here we go. Could you improve this, guys, please? So basically what they want us to do, it's not an unreasonable request, is get rid of that ranking column, please, and then to replace it with a customer segment table, and then a foreign key from our customer table into this segment table. So our segments are going to be reference data, a reference set of segments that will be assigned, customers will be assigned to these based on their order total. That's the kind of idea here. So look, it's a little contrived, okay, so but it'll work for the demonstration. And please, nobody build their database quite like this.
Absolutely not.
So the first thing we need to do is go ahead and, in fact, let's just take a look at the task list. Do you have that list of things we're going to do?
Yes, I do. Just one
moment. So we have to go through, we have to do a few things here. So there we go. So this is our connected tasks. This is what we're going to do. We're going to remove the ranking column. This is the work we're going to do connected here. Then the rest of this is going to be done in the second demo, which is the offline or project demo. So we're going to remove the ranking column. We're going to create a segment table. We can add a foreign key from the customer table to that segment table. Then we need to fix up the view. The view we just looked at, we'll need to use that, a join across the customer and segment table. And then we'll add a stored procedure that's going to use the order total of each customer and use that to compute and assign customers to the appropriate segment. So that's what we're going to set out to do. OK, so let's get going. I can watch what's going on here. So we're going to go into our new table designer. This is a really cool new feature. Now we are working declaratively. So just take a look at the code at the bottom for a moment there. If you just scroll up to the bottom of that mark in the code section, you just focus on the fact that we are looking at, if you go to the top, actually, this is a create table statement. So we're working declaratively now over the definition of the database. So we opened the table definition, and we're going to make changes to this definition, and then the system's going to work out what it needs to do to the database to apply the changes we're going to make. That's the point. Now, we're going to come back to this several times, but just in summary, so you'll see more of the way this tool works as we go through. But in summary, we've got a design pane at the top, code pane at the bottom. These could be switched around. They're synchronized, so changes I make in one are automatically applied to the other. And we also have a sort of logical view on the right-hand side, so I can drill down into some of the objects, and it'll highlight columns and elements in the code that participate in the definition. And then one last thing before we get into this is that code at the bottom. Think of that as a code representation of the model. Yeah, it's not really code. It is code, but it's a code representation of what's the knowledge in the model. I'm not just writing out source code at this point. OK, so we're going to delete this column. So let's go ahead and delete ranking. And we'll delete this from the model only at this point. I think you could...
Just one moment for effect here. I'm going to delete here.
OK, there we go.
Yep.
And if you can see, just in the bottom on the left-hand side in the Explorer, you can see the column is still there in the database, of course. We haven't actually applied the model change to the database. Now, that was an easy change to make, one click. But if we open up the error window at this point, we can see the result of validation, which is going on all the time against the model. In fact, that column, the ranking column, is referenced in a view. Well, not surprisingly, it was referenced in the view we just looked at a few minutes ago. That view is schema-bound, so the column can't be deleted without us deleting the reference. At least that view can't exist in the database containing a reference to a column that doesn't exist. So we need to go and fix up the view. So if we double-click on the error, it takes us to the view definition. And pause again for a moment. Look at the create view at the top. Again, this is a create statement. This is the definition of this view. We can see the columns there, the references to ranking are highlighted, they're squiggled. So we need to remove those references before we can apply the update to remove the column there. So let's go ahead and do that. Mark's going to comment these out for now because we're going to come back and fix this up later. It'll be kind of easier to see what we're doing because we have to replace those entries later.
Notice so my errors have disappeared. Everything's good in the world.
Yeah, the models are now clean. So now we're good to update the database. So there's a nice big button up there that says Update Database. Go ahead and press that, and we get the same preview. This time, of course, we're not going to be chicken. We're going to go ahead and actually make the change. But let's just remind ourselves what we're looking at here. So notice, again, the warning about data loss. Of course, this time we're kind of glad there's going to be data loss. We're getting rid of that crummy ranking column. No major concerns in the highlights, and then the work to be done here. We're going to unbind a view before we can make the change, and we have to fix up the view afterwards. So let's go ahead and, now at this point, we could trust the tool and just make the change, or we could verify and look at the script. So let's go do that. Let's go take a look at the script. And the thing to remind yourself is this is the script that you would have to have written manually if you were going to make the same change. So this is, there's a fair amount of code that you'd have to have written to make those 2 clicks that we did. I think it was 3 clicks. Yeah, it was right-click, delete, and a couple of commenting entries. And it's a significant amount of script that has to be done here. If you're going to do the job properly, the kind of script you'd hand off to a DBA and be proud of. OK, so let's go ahead and submit this. We're going to execute this. And at this point, it updates the database. Now, I'm actually going to pause here for a moment and sort of rewind. When we looked at that preview, I want you to understand something here. We looked at the preview. I talked right at the beginning about drift detection. I should have made this point when we were looking at the preview. But and when I said there was a model of the database, well, I sort of lied to you because there's actually 2 models of the database. There's a model of the database that we build, which you edit, and there's another one a copy we take of the one on load. So we actually hold 2 models of the database, so that we use these 2 models to diff between the 2 models to work out what to do to apply changes to the database. But just before we build the script, as we did there, we actually go and drift detect this one here, the model of the database. So if there's been any change to the database, we discover that and reload just the changes. So when we actually compute the script, we're doing it with the latest model. All right? So that's how we're handling drift detection, late-bound drift detection. Now, I guess if you hang around for a long time, it may drift again. But if you've been working for several hours with the tools, then the possibility of drift occurring is that much higher.
So I'm really happy now, Bill. My ranking column has disappeared from the left-hand side of Server Explorer.
All right, so this is the end of our connected segment here. We've accomplished our work. We got rid of that ranking column. Let's go back and just remind ourselves what we saw. We saw an SSMS-like Explorer.
Tongue twister time.
That's time. And we saw a query window where we're able to submit scripts and queries. So we still need that. We understand the need for that. Then you saw our buffered declarative approach. Buffered because we're holding this model as a buffer of what you are doing. Which declarative, you saw the whole time we were working with these definition representations. And it's model-based. It's away from the database. In fact, you can sort of imagine it's sort of disconnected even while connected. That's kind of a way I think of it. And we saw error detection going on over that model. We also saw a code-backed designer with the experience there of working in either code or in the design experience, in the design surface. And one of the cool things about that is I think you can give that tool to either a coding guy or a designer guy, and they're each going to be happy. They can each choose to hide the other and the other part of the tool they're not interested in working with. And of course, we saw this kind of modern T-SQL coding experience we've seen in IntelliSense and code coloring, tooltips, and we'll see more of that as we go through. OK, next demonstration, offline development. So we're going to continue. OK, let's just take a quick look at the tasks we have to do here.
Yes, the tasks.
So we managed task 1 just now. And now we're going to go create the segment table. We're going to add that foreign key. We're going to update the order summary view, create a store procedure. And then in the next segment, we'll do the deployment to Azure. So let's go ahead and do this.
OK. OK,
so first thing we do is go back to our database and create a project from it. Now, nothing I'm doing here requires us to do this. We could do all of this work connected, but we're just going to choose to demonstrate this capability for you. Of course, working with a project means I tap into all the kind of Visual Studio goodness around projects, source code control, lifecycle management, etc. Now, what it's doing now, and you kind of got the story, I think, by now, we build a model from the database. Now we're going to use that model. We're going to actually generate a bunch of create statements, T-SQL code, all of which is declarative in nature, and populate the project with that. That's how we're doing. So it organizes this in our solution. So we'll open a the Solution Explorer moment. We're going to sort of shift now from left side to right side, from
there we go. All
Server
done.
Explorer to Solution Explorer. And in the left side, you saw it organized, the tree organized in the way that's familiar to SSMS users. On the Solution Explorer, we tend to use, as just the default, there are other options, an organization that's more namespace-oriented, more consistent with the way that developers tend to work. So here we have, for example, we double-click this guy and open this. This is the customer table.
Gosh,
so
Bill, this looks familiar.
Yeah, it's the same. That's the same tool, of course, running over the model, but now running over a source code-backed model rather than a database-backed model. OK, so before we go any further, we're going to take a snapshot. We'll talk much more about snapshots later in the session, but that's the next thing we're going to go do.
That's done. And those live down here in the snapshots folder so that I can actually find this later. I'm going to rename it. I'm going to call that V1 baseline, for reasons that will become apparent as we go along.
Yeah, so this is sort of like, from a project standpoint, this is our baseline state of the database. And you're going to see us gather a kind of library of these snapshots as we go through the session. OK, so the first thing we had to do was add the segment table. So let's go ahead and do that.
Nice, friendly new table.
OK. So we're going to put this in the right schema. You can see in the right-hand side there, we've got sales LT schema.
I think we should give this a friendlier name for the ID. So we'll go segment ID.
Let's give it a segment name and a description.
And this should not allow nulls. And we'll give it a segment name, which will be an nvarchar 20 in this case, not 2. Also not null, so we'd better change that value. Now notice as I click this that you see the changes synchronized down below. So I could have chosen to type in either place, and in fact that's what I'm going to do now. So I'll go and put in a description field. And as I do that,
you can see as intermediate states are in error, it pauses waiting for you to get to a point where we can parse that as a valid statement and update the design pane.
And sure enough, everything is synchronized.
OK, that's good. That's nullable. Now we can also edit with the properties grid. Let's hit F4 maybe.
OK, let's F4 away. And sure enough, so let's imagine that our description field here,
Let's just go ahead and
want to make that a max. Sure enough, we see everything is synchronized between all three.
That's cool. OK, so that's our table designer. Kind of good illustration now of the way these various pieces are kept in sync here. Very cool tool. OK, so let's go ahead and save the file.
OK.
And so there's a point. Save the file. Same experience. Previously, we were saving to a database. Now we're saving to files. We've got basically a persistent form of our buffer that we're working with, which is our project system. OK, so now we're going to go and add the foreign key from the customer table to this segment table. So let's go and do that.
Meanwhile, back in the customer table, we need to add a segment.
This is just a little crude at the moment. We have in works a nice new foreign key design experience that we hope to be shipping with this. Mm-hmm. But for now, we'll go ahead and we'll add a foreign key. So this is going to add the constraint over that. And we get a template, and we go and type over the template here.
Yes.
I need sales LT. I'm Mark's conscience here as he types.
I wish we could implement a bill feature, don't you think? It's the guy that would keep me honest. segment ID. And we're ready to go.
Okay, so the
No redness.
squigglies go away. All right, so at this point, our major structural changes to the database itself are complete in terms of our improvement here. So let's go ahead and hit F5. That's what you do with a project, isn't it? So let's do that. And it's going to go ahead and it's going to build it, basically compile that code we've written, and it's going to deploy it. But where's it going to deploy it to? That's interesting, because we've made no statement about where this should go. So by default, with SSDT, it's going to deploy a project to a new, and in fact, it's basically being announced today. Sort of, if you didn't catch it in the keynote, it's being announced now. A new local database runtime, which is a new feature in SQL Server Denali, which is shipping with Denali. It will ship and be installed with SSDT. That is a local database that you can run on your desktop, and it's a single user, single instance, on-demand activated version of SQL Server. Incredibly cool, lightweight test and debug feature, if you will. It also can be used for application scenarios, in incredibly lightweight application scenarios. But its number one scenario, certainly for us, is this test and debug scenario you're seeing us use it for now. So it shows up here in our SQL Server Explorer as a new node. And if we expand there, we'll see we've got the database that we were working on. It takes the solution, the connection takes the solution name and the database. There'll be a database for every database project that you have here. We just have one, of course. So you'll see that showing up there. And we drill down, and we can see, and it took a couple of moments because it did deploy the whole database. Every change we make from now on, it'll just do incremental deployment, so it'll be much faster.
That's right.
And you can see the table we added there. Now, the next changes we have to do, we have to add the view and add the store procedure. It'd be kind of useful to have some data in the database to go test with. So let's take a look at the segment table there. And Mark can go and type some data in here. It's pretty boring watching Mark type data in, actually.
It really is.
So we can get one row in, and then my patience expires. But we have a source of segment data, which you saw earlier. Actually, we have that spec we were looking at.
Meanwhile, back at the spec.
So let's go back to the spec. And we can go grab some data right out of that. No, that's not going to work. Go grab some rows there. So we can grab, it's a table, isn't it? So it's a table in Word, table in a database. What's the difference? So let's go grab it from there.
Oh, got a little overexcited there and pressed Control-V twice, so I'll back off.
So just
All
double-click on the description there, and there you go. So we've copied data in from Word, so that was pretty cool. And now we need to go and get some customer data. We need to go and have, join customers to this segment. So let's go grab that.
Let's look at the customer table.
And we certainly don't want to watch Mark type this in. It's way too long. So we're going to go back to our original database where we had a whole bunch of test data. We ran those queries at the beginning. We'll grab some data from there. So let's go do that.
So up here we have a suitable source. You can see it's got lots of data in. So I'm just going to grab a representative sample here, copy it, flip over to my old local database copy.
So this is kind of, no one's going to do data entry seriously with this, of course. This is all about just...
This is not
what do you think?
One more time with feeling. You're quite right. Goodness, somebody was watching.
So let's go back and change it.
I think we should fix that, don't you?
My goodness me, it's
so it's in customer,
in customer,
which we need to fix up from the project. Somebody was watching well. Thank you, sir.
There we go.
Very good.
All right, so let's hit F5.
Somebody gets a free shirt for that. Come see me on the stand later. Of course, we can't really do it until we've deployed those changes, can we? Got to flip back to customer. F5, deploy our changes.
There we go, you should still be in the paste buffer.
One more time with feeling. Hurrah!
There we go. Thank you very much.
Thank you, I owe you.
All right, so let's scroll across to the right. And actually, we have a fix for that kind of little repeating error there that we saw. And
right.
there's our segment table. And now let's put some entirely random segment assignments here. And if you stop and think about that, that is actually entirely random, that assignment. OK, so we're sort of ready to go with the view definition. Let's go back to the view. We need to pick up the pace here. So let's go into the project, find the views, and open that view. Now, this is the view that we edited before, so we should see the commented out entries. There they are. So we're going to add a join now to the segment table. So let's go and add that.
Yep.
This is going to be a left outer join. This accommodates the possibility that customers are not actually assigned to a segment. Again, we get our nice IntelliSense as we're going. And again, this is a view definition.
Right.
Again, we need to fix up the group by and the projection. S. Segment name. No, you're still doing it.
Sometimes IntelliSense doesn't help.
I'll just copy that.
Okie doke. We have what we need.
OK. Like watching paint dry. Sometimes there's sorry.
Thank you, Bill.
Just more exciting. OK. So let's execute this. Just hit
You
Alt
think we
X.
should?
Yeah, execute this. What the heck?
Execute, yes.
Be brave.
Oh!
All right. So there's an error. Can someone point out why there's an error? Well, it's a create statement, isn't it? It exists already. We can't run this. So this is. But we can do something. Let's go grab just the select statement. So we can run that though. So here we are connected. We're doing this declarative definition, but I'm able to execute these subqueries, pieces that aren't actually declarative in nature. I can run these. So I can debug a view as I'm working on it. I could debug a stored procedure and the complex subqueries. I can do this. Something is just fast pathing me to get this into the data before I get this into the database.
So I should take a look at the old execution plan.
I can look at the execution plan. There we go. That's cool. All right, so this looks good to go. But, looking at this, we just minimize this or push this guy down.
Oh, I think we can do that.
Looking at this query here, we've used segment as the name of the table. And it's kind of a generic name, that. I think maybe, because maybe we're going to have a product segment in the future, maybe we should have picked a different name. I'd like to have used customer segment, Mark. The problem is we've already deployed this. We've got a database now with some test data in it. So how do we make this change? What I need to do is to refactor that code, of course. So we right-click there. Well, we could do this refactoring. So yes, you guessed it, we have refactoring support. So we could do this right here. But I kind of like the idea of going back to the definition of an object and refactoring from there, from this sort of baseline. So let's use that, go to definition. So you can see us using common Visual Studio code navigation paradigms here.
Yep.
And from here, let me go find out all the places this definition is used before I change it. So let's go look at find all references. So again, there's a very common Visual Studio code paradigm there. And we find 3 references. Well, of course, the first one is the definition itself. It's what we're looking at right here. The other 2 are the things, the view definition and the foreign key that we've been working with. So this all looks good. Let's go ahead and refactor it. So let's right-click there. Refactor, and we're going to rename this. And we're going to make this customer segment. And then we're going to see we've hooked into the exact same refactoring experience that you get in Visual Studio. So here we can see the references, the refactoring, and the impact. All looks good. Let's go ahead and apply this. And now with this applied, let's go ahead and deploy the change. Let's go and hit F5 again. So that takes us through our compile, build, and deploy this back to the database. And of course, the interesting question is, what did it do to the database? What did it do to the table in the database?
One way to
Let's go
find
take
out.
a look, and let's just wait. Let's just have a look what we got here. open it up, open it up, open it up. Everyone's desperate to see what we've got. So look, there's segment. Oh, but we renamed it. We renamed it. What's happened? What's happened? So we just pause a moment.
Ta-da!
So it's about 30 seconds polling there on a refresh. So we refresh that. You could hit refresh, and we could have seen that immediately. So it's going to take a look at the data inside that. So because it was a refactor gesture, we understand, the tool understands that we renamed the table. We didn't just drop it and delete it. So remember, we do this model comparison. We factor in the refactoring information. So we renamed the table. And you can see we preserved the data in so doing. So the tool does the right thing for us here. So that's very cool. OK, so the next thing we need to do, we fixed up the view. We now need to go and add the store procedure. This is the store procedure that's going to go ahead and classify customers according to their order value.
But since we've all seen how terrible it is to watch me type.
Yes, I twisted his arm, and we convinced him to have this one on the toolbox.
There we go.
OK, so this is a simple store procedure, probably not the way you'd write this for real. You can do this more declaratively. But what this does, it simply goes and finds all the customers, goes to that order summary view we've been looking at, pulls them back, and then iterates over them, and looks at their order totals and assigns them an appropriate segment ID. So that's all it does. Very simple. So let's go ahead and put a breakpoint on this, and we'll go run it. So hold it F5. So that'll deploy this into the database. Then if we go, and we're going to go back to our query window and run an execute script, execute statement. So F5 puts this back into our local debug database.
Right. And we're going to hop back. I haven't got a query window open. So
Just push that. All right. There we go.
Going to need a query. And we'll just run that procedure. Sales LT again. USP classify customers.
And we're going to run it this time under the debugger.
Sure
there we go.
enough.
In the debugger, hit F5, goes forward to the breakpoint. So here we are debugging now right inside our SQL Server store procedure. And we can step through there. So now we have the normal Visual Studio debugging experience. So in this example, we don't actually have any order data in our little database. We didn't copy any order data into our local database. We could have done. So Mark can actually simulate this. He can add some values here. So we can use the locals window and enter some example values. And,
looking good, Bill.
OK, good. Just a couple there. And step through. There we go.
We'll try one more time with a different value. Because, you know,
this is exhaustive testing we're going to do here.
Yep, looks right again.
OK, so let's hit F5 and take this to completion. So now, we probably should do a little more testing than this. This was just a little extreme. So it'd be kind of cool now to take this back to where the data really was. So let's go take all the work we've done in this section and put it back into the original database. So the way we're going to do that is use schema compare. So we're going to compare the project against the database that we used to source this. So that's obviously the database that we know existed beforehand. So we right-click on project, pick schema compare. So the project is our source. Now I'm going to go pick the database as our target for this comparison. And basically, we're telling, remember that differencing engine, the comment I made about that. We're telling it which database to find a schema from here. So we're going to take two models, the one we were working on, and then a particular database model. And we're going to compare those two to work out what's different between them.
We're just going to have to wait a moment, chaps. I know exactly what's wrong. There was a missing point. Make sure we're connected to the real server. This should be a little quicker now. And we make our comparison.
OK. So it's going to find all the things that are different between these two. And if we organize this by action, it'll nicely summarize this by the changes that need to be made. And we can see very quickly here, very simply, we need to have, we've got various items being created. The customer segment was new. The store procedure was new. And we're updating a couple of things there. And you can see at the bottom, we get this nice code diff as well. So we're seeing the differences between the code in the source and the target. So at this point, we could script the changes, but we're going to go ahead and update the target, which in this case is the database. So let's go ahead and do that. And we're almost ready to go run our stored procedure against that set of data, the live set of data now. One last thing we need to do is actually take the segment definitions to the target database. They only existed in our test database, which actually is kind of like a little entree to a point we're going to make right at the very end. These are a good example of reference data. And one of our goals is to allow you to define reference data like these segments as a part of the database in the schema and actually treat them as schema so it would be deployed as part of a deployment.
So here's our data.
So this time we're going to script it out. Last time we used copy and paste. That was, you've seen that once, that trick once. So here's just a quick script we can produce there. So we can copy this out. And now we're going to go back to the database. So back to AdventureWorks 10 there. And open a query window again. And we just paste that in and run that script.
And we're just going to execute.
There we go.
Done.
Now let's go run the stored procedure. So the stored procedure now should do the proper job of classifying all of our customers against those segments here. So that's what we're expecting it to go do. So we run that quickly. And then just to prove that work, let's take a look at that query we started with. So that's select star from the customer summary. There we go. And now we should expect to see our customers all nicely segmented. There we go.
Isn't that marvelous?
So there's the kind of loop complete, back to the beginning there. Okay, so that's our offline kind of project-based demonstration, ending up back online indeed. So let's go and summarize what we've seen there. So we saw managing the database definition in source code in Visual Studio. So you saw us creating that definition of the database there. You saw us looking at various advanced language services. We saw the go-to definition, find all references, and you saw the refactoring demonstration there. And then specifically, in particular, we saw that the local debugging experience using this local database runtime, this new feature in SQL Server Denali. And lastly, the schema change. We applied from the project back to the database, driven through our visual head over the differencing engine. That's our schema compare feature. Okay. So that's sort of the main arc of the change, of the improvement. So we now need to we were now challenged to also put a copy of this database up on Azure. So let's go ahead and do that.
Okay. Meanwhile, back on our machine.
Okay, so at this point, you've heard this comment about targeting. So we can target the same database project to different editions of SQL Server. So here you can see the list of targets. And we're going to pick SQL Azure now. And the key thing this does is it kicks in a new level of validation that is appropriate to the edition you pick, the target you pick here. So we'll get, if we were typing, we'd get syntax errors now if we use syntax that was not supported by Azure, for example. There are also changes that are more subtle that require a build to find, and we'll see that in just a second. While we're here, we could also go pick the DAC option. And if you watched the keynote this morning, or the foundational session this morning, you would see Roger actually used the DAC pack here as an example. He did that. He produced the DAC pack at this point and then used that to deploy to Azure. Now, we're not going to do that. We're going to show you another way of doing it, which is to do a direct deployment. But before we do that, we're going to do is go ahead and build the solution. Because what we're going to find is that while we think the database is OK to go to Azure, there's actually one warning here. It's kind of interesting that it's a warning, not an error. It's a warning that there's no clustered index on this table. Now, Azure requires a clustered index to be on a table. It needs there effectively to be a primary key on every table. And why is it a warning, not an error? Well, it's kind of interesting because, of course, in SQL Server land, it's entirely OK to deploy the table because you can come along afterwards and alter it and add the index afterwards. So it's a warning to you. If you were to try and put data into there, though, you'd get a runtime failure. So we want to go fix that.
Better fix that up.
Nice and simple, right-click, set primary key, and now we're good to go. If we were to build again, we'll see the error, the warning goes away.
And sure enough, no warning.
OK, so now we're good to publish this to Azure. Let's go and do that. This is where we have kind of collective inhalation and holding of breath. So let's go set up the, we can go load a profile here. The profile is a way of saving connection information. So I can, well, Mark can go grab a profile.
Okie doke.
Save setting up that connection string. And we could generate a script again at this point, but we're going to go ahead and publish. So let's do that. And this database activity monitor here lets us see the progress of this activity. So again, it's a full deployment, so it's going to go through, take a few moments. And of course, what it's really doing, remind yourself, is this. It's actually going to Azure and saying, bring me a model of the database. Oh, there isn't a database. Create the database. Give me the model of the database. The database is empty. Compare that model to the model of the database I've got. It's full of things. Let's go put all those things into there and push that up to Azure. So it's doing a model compare to do this still.
It's done, Bill.
OK, so let's go take a look at our Server Explorer.
Okie doke.
And we should now see,
Just expand that out a little so that we've got some space.
let's close down the local node there.
And
So
look,
there's our Azure connection. So added a connection here to the Server Explorer. And we go expand that guy. It's going to go back to Azure, pull down the latest version of that database, just in case it's drifted. And if we go expand that, we can see there's the database that we've deployed. And if we were to double-click, let's say on customer again,
let's take customer.
just as a random example, just because we've used that before, here again is the table designer opening up. So here's the sort of full arc here. We've gone offline, and now we're back connected again over the Azure database. So I can connect direct to Azure. I can edit databases right on Azure. And if you think about what you've seen a whole offline story. If you take the local database runtime and Azure, those two together, it's like a marriage made in heaven, the clouds. Anyway, this is sort of like they're meant for each other, aren't they? It's an incredibly lightweight development story for Azure now. So with SSDT, local database runtime, I can build and test Azure databases on my desktop and then pump them up to the cloud. Really cool. OK. So that's our Azure demo. So you saw this kind of target aware. So how we could go pick targets and get the target-specific validation. We happened to pick SQL Azure, of course. That was the nature of this demonstration. You also saw how we could publish direct or via scripts or using DAC. And again, you saw the DAC story played out this morning in Quentin's keynote, if you listen to that, if you watch that. And if you did see that, the wizard you saw there, the whole process that's going on, there actually it hooks up to the database, looks to see if the database is still the same one, based on the same DAC, does the same drift detection story. Actually, it's using the same underlying technology. So we've got the same engines at work here fundamentally in these various tools. Very cool. And that same wizard that you saw this morning doing that same experience will be available from here in SSDT, so you don't have to use SSMS. And on that point, let me just make a remark about SSMS and these tools here, because we're often asked about this. We're not setting out to replace SSMS. SQL Server Management Studio is focused on SQL Server Management. That's the name of the tool. Our goal is to build a solution here for development tools, and to cut down the need to Alt-Tab between these tools. In the past, people still end up spending a huge amount of time in SSMS when doing database development. So our goal is to find all the tasks and features of SSMS that are sort of routinely used by developers and bring those over eventually into SSDT. We haven't done it by any means in the first release, but you'll find that's our goal here. We're not trying to replace it, just trying to give you a new home as a developer working on databases. Get everything done in one place. OK, and of course, the sort of big thing here is this whole offline and connected story for Azure. So the fact that we've got an offline story and a connected story, both of them housed in SSDT here. Brilliant. So the last demonstration. And I've talked a lot about the sort of development process, talked about the difficulties in the process, introduced the talk with that. So let's kind of come back to the kind of process aspect of this. Earlier on in the session, I took a snapshot. And that was our V1 baseline. So we finished our V1 work now. So let's take another snapshot. Let's call this one V1 complete. This is the sort of where we're at, if you will, in terms of our V1. We deployed it into Azure. That was our V1 goal.
V1 complete. Oh, hang on. Nope, I don't want to do that. I want to rename. Complete.
OK. So now in our scenario, time passes. Time passes before we get the summons to make a second change to the database. In this time, a database administrator happens to come along and takes a look at the work that we've done in our first project and fixes a kind of performance challenge that we left behind in our work. So Mark, to simulate the database administrator at work here, has opened up another SSDT instance. Of course, he'd probably be using SSMS, but who knows? And he's going to go ahead and add an index. So we get to watch Mark type again. So he's going to add an index on that foreign key column from the customer table. It's the kind of thing that an administrator might do to tweak the performance, just a minor change to the database. But it's the kind of thing that can catch you out. You can find yourself losing track of what's been done. Mm-hmm. And he added that in a script window.
All done.
All right, so the DBA goes away. Now, of course, looking back at this, there's little evidence of that change that's happened here. I mean, indeed, if we were drilled down, we'll see that change has been made to the database. But as a kind of matter of principle, starting out this next stage of our project, we might go to the database and drift check the database against our project. So let's go do that. Let's go do a schema compare. We can use the database as our source this time and compare it to our project. So this is sort of, here we are about to start our project, our V2. We pull the project in from source code control. We didn't do that in this example, but we could easily have done so. And now we compare the database. Has the database moved on from the way we last looked at it and think about it from a source code standpoint? That's the question we're trying to answer here. Mm-hmm. And indeed, we find it has. So let's go by type. Yep. So we see there are two changes being shown us at the top there. And it's kind of worthy to expand these and think about the two of them. So the top one there is a change. Which one is this?
This is this guy.
This is the change to the primary key. So this was the work that we did in the Azure version just now. We added the primary key. Now, we don't want to lose that. That change wasn't required. But let's make the assumption now, this is, I think, reasonable, that primary key is good to go. We want to keep that in our story moving forward. So we'll keep that change.
So let's take a look. Uncheck this guy.
Yes, so because we're actually being told here is that the database doesn't have that primary key. So if we accepted the change, it would actually remove this primary key from our project. It would say, hey, your project's different, doesn't have this primary key, better take it away. All right, so we're going to uncheck that change. We don't want it to make that change, in other words. But we do want it to make the other change, which is the index. So we'll now let that one go through. So now we say update target, and our project now represents the best of all worlds, if you will. It's got the work that we did on Azure, and it's got for the primary key, and it's got the index change that the DBA did in the meantime.
Time for a baseline, you think, Bill?
I think, again, yeah. So a V2 baseline snapshot. Okay, yep. Now we need to keep rolling here. So our V2 work, it's going to be very quick. I'm not going to go do anything elaborate. We're actually just going to add another view. So let's go ahead and, in our project here, add another view. We have this sitting tucked away on the side.
And this one is the customer segment summary. Sure enough.
Okay, so we're going to add this view. So this gives us and we could go through the whole deploy and test and thing. You've seen that all before, so I think we're good there.
So we'll just hit the button, shall we?
Yeah, we'll just we can just go ahead and deploy it. But what's significant is that here we are, we're at this new place where we've got so let's now take another snapshot. Let's take our Finally. V2 complete. So this is our V2 work done. Now, we added a new view. This view, by the way, will give us a summary of the order totals by segment. Not unreasonable next thing to go do in our little project here. And you can see now, with this extra snapshot taken, how we've got this kind of library of snapshots taken. And what you can see is, quite apart from our source code control story over differencing among the definitions, if we check each of these at each of these stages, we check into source code control, we've got a mechanism here, right here, inside the tool, inside the project, if you will, to actually look at and to maintain a difference history over time. Now, there are various things I can do with this. I mean, a very straightforward and simple thing we can do.
Schema compare, Bill?
Yeah, would be to, for example, let's do the compare between the V2 complete and the V1 baseline. So this would be, so you can see I can actually now compare, because what we've done is these are serialized forms of the model itself. So I can now open these snapshots up in the tools and look at them and compare with them, for example. So this comparison, we go ahead and do this. Will let us see everything we've done in the demonstration, barring the very first things we did connected, because we didn't take a snapshot before that point. So there, we look at this by action.
Yep, we can see our.
So there we go. And you know, I don't want to dwell on this. You've seen schema compare, but you can see the value of being able to do this. But think about some other scenarios for using snapshots. For example, I could send a snapshot with a diff, with my script. In an organization where I don't get to update the database, I have to hand off a script to a DBA. I can send the snapshot and the script to the DBA. The snapshot is then used by the DBA to verify that the snapshot is what I think the database looks like. So the snapshot can be compared by the DBA using a command line tool. He doesn't need to bring up these tools. It can be compared against the database to see if there are any significant differences between the actual production database and the database that I've based my script on. So he can understand whether I need to go back and make changes or whether it's safe to apply my script. Another interesting scenario, if I was an ISV and I'm sending a database to my customer, I may not have a copy of the database that my customers have, but I can keep these snapshot definitions of the way I have sent databases to my customer. So now when I am preparing a new release of a database, I can compare my project to the snapshot as I understand this customer's database is. And without access to a database, I can still provide that customer a script that he can use to actually deploy in his data center against his database and be successful. OK. So very quickly, a summary of this. Drift detection, you saw us synchronizing, in this one, synchronizing a project to database drift that had occurred elsewhere. And you saw and you heard me talk about the scenarios there for using these snapshots in various lifecycle management scenarios. OK, so that's our cycle of demos complete. So I promised you we weren't going to spend lots of time on slides. Hopefully the demonstrations were interesting. And hopefully we've kind of like set you up to try these things out for yourself. So when can you get hold of this? So everything you've seen will be shipping with SQL Server Denali. So we'll be shipping when SQL Server Denali ships. There will be a CTP of this in the summer. That was the phrase used this morning. We have to be very careful what we say about these things. It'll also be available on the web. So we will make sure that we have our tools available on the web. And we will be shipping there with SQL Azure in the sort of cadence with SQL Azure releases. And also, the tools will be available in Visual Studio vNext. In terms of the kind of directions where we're going with the tools, we have just as long as our arm, longer than my arm at least, a list of features and improvements we'd love to do to the tools. Lots more things we'd love to hear from you about. This is just a kind of a snippet here. If you've heard at all about SQL Azure federations and sharding, one of our first SQL Azure features is going to be sharding support. There'll be probably a couple of releases we'll issue where we'll be supporting that. So that'll be coming. Application database integration, probably available on the web. And that's the other kind of like big star program available. You can go see that
on Wednesday.
On Wednesday, yes, this week. So there's another show on that. And that's a super exciting demonstration showing how application projects and database projects can be kept integrated. When the application projects are using Entity Framework, it's just a beautiful story around synchronization between the two. Definitely worth seeing. It's really cool. And then on the horizon, other things. I mentioned reference data earlier, this idea of having data inside the schema, treating it like schema. So whenever you deploy a database, we ensure that specific data values are always there. So that's a kind of a super new thing we're looking at. Database diagrams, we want to go to a more graphical story. So now we've got this data model, database model here, there's lots more things we can do. So think of much of what we're doing in this first release of SSDT database services as paving the way for lots more things to come, giving us an infrastructure, this declarative infrastructure we can work many more things on top of. And a query designer is another one of those, again, a set of tools for professional query design. Okay, so that's there. So sort of, I hope you feel that I made a case that there is a better way than the kind of imperative, script-oriented way that database development is so often done today. So we've talked to you about this, and I must have bored you by now, on the declarative nature of the approach, the fact that it's model-based. You've seen this integrated set of tools, the same tools running connected and offline, and the modern language services. You saw IntelliSense, code coloring, refactoring, all sorts of code goodness there. And you saw this local database testing with our local database runtime, which we announced today. And of course, the whole SQL Server and SQL Azure multi-target, one project, two targets kind of story here, or many targets. So in terms of follow-up on this, we'd love you to basically watch this space. We're going to make announcements on our website and blogs of the availability of the CDP. So we'll be just super keen to have you guys try the tools out, get some feedback from you. Please go there. Please watch the forums.
And please come and see us on our stand.
Well, indeed, yes. This week on the stand. And so in terms of
Click it on.
I'm not sure. All right, I'm sure they took my slide out. So there are many other things going on this week, and these are just some examples of those.
If you want to find other talks around us, just go to the session machines and type in Juneau, and you'll find everything you need to know. We've got a hands-on lab on site as well, so you can actually get your hands on these bits ahead of the CTP. So go have a try at that. Let us know what you think.
Yes, and Mark and I will be on the booth various times during the week. I'm delighted to talk to you. Thank you very much for your time.
Any questions? If you have questions, would you please step up to the mics for the benefit of the recording?
And please do fill in your evaluation forms. We'd love to hear how your feedback on the presentation. Thank you very much.
A couple questions.
Yeah.
We got the mics live, please. Sound guys? Yeah, got it.
There it goes. Now where did I left off? The reference data piece, you said that's going to be post this first release?
Yes, it will be, yes. So the question was about reference data. Yeah, I'm afraid that will not be in our first release, but it's something we're looking quite strongly at. We have a prototype of it running, actually. Very cool.
And then from kind of comparing this to what was in the Visual Studio SKU, I mean, it looks like the biggest difference is some of the designer aspects, right? I mean, actually having the designer in there. I mean, the idea of the model data and the declarative design and the deploying the schema version versus deploying alter scripts is all.
Yes,
that's been around.
Yeah. There's a lot of the declarative work, and I said we're building on top of that. Big thing so you picked up the designer, but also the whole connected experience is really new. This buffered experience when you're when you're connected when you're connected to a database. That's all new. That wasn't there before.
We've got another one over here. Mm-hmm.
Yes, please. You have a question over there?
Carry on.
What versions of SQL Server will you be able to connect to on the source?
The question is, which versions of SQL Server? So we're supporting it's the supported set of SQL Server versions at the moment.
2005, 2008, 2008 R2.
That's correct.
Correct.
Yes.
Yeah.
Yes.
And of course Azure as well. Come on up. Next. Yep, that's going.
Yeah. No?
Yep.
Yeah. Can you compare snapshots and labeling in source control? When should you use one or the other?
So can we compare snapshots and labeling? You mean like can I contrast the two?
No. Well, why do you have two mechanisms for versioning?
You're saying why do we have two mechanisms?
Yes, for versioning.
So it's not versioning per se, because you can't unpack a snapshot into it isn't the source, but it's a rendering of the model. I mean, it's not only used for versioning. You saw the other scenarios so we use that to pass that around. So we have those. and you can version them. And I mean, you could choose not to store them if that's your decision in source code control, but they are there and can be used for that purpose. So understand they are not per se the source of a database. So it serves a different purpose than a labeled source inside TFS, for example.
Right.
Okay, another question?
Do I understand that the toolset is going to ship with the SQL install media the way that BIDS does now, will replace BIDS? In other words, available to install without it being
I can talk
a
to that, Bill.
licensed SKU?
Yes, so the BIDS license will be within SSDT.
Right, but I'm saying SSDT will ship, be installed, and available the way BIDS is now.
Yes,
That's correct, yes.
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 That's correct, and it will also be available on the web. So that's a very important distinction because BIDS historically has not been. But
Yes, and the way it works, of course, is if you have Visual Studio installed, then it lights up these tools inside Visual Studio. If you don't, you get a basic shell with the tools in at that point.
Thank you.
And everything you've seen is Visual Studio 2010, of course. So it will be BIDS and the database services all sitting side by side in Visual Studio 2010.
next question.
Now that we have moved all this stuff from Management Studio to this tool, what is the future of the Management Studio? Do we still have that, or?
Yes, well, I think I tried to touch on that earlier, that you shouldn't think of this as moving on from Management Studio. Management Studio will continue to exist. Its goal has always been, as its title suggests, a more management-oriented focus. Obviously, it's been used as a development tool. Our goal with this is to give developers a real home, if you will, in a tool. So SSMS will continue, and they'll continue with sort of parallel lives, and there'll be some sort of cross-fertilization between those two tools over time. But we're not announcing any changes in that at all.
No, not at all.
Another question?
Yes, please. Actually, if you don't mind, I've queued up 3 really quick questions.
Okay.
I think I have more, but that's all I can keep.
You may have to ask them one at a time. I can't remember 3 questions.
Yes, I will. It's actually all in context to the fact that we use the tool with the very long name Visual Studio 2008 Database Edition, GDR R2, which it seems like just a precursor to this.
Yes.
So I'm looking like for specific things, and I'm wondering what we could look forward to with the new version, aside from the features you covered. One is performance. We actually have a pretty big database, and as a sort of add-on that the GDR R2 seems to be, the developer might be stuck waiting maybe 10 minutes for the whole thing to load before they can do certain activities like a build.
So we've certainly addressed performance in this, and we believe we've improved it. But I'm not in a position. You would need to know how big your database was. Turns out it's not the size of the database that's the big factor. One of the issues for us is the complexity of things like stored procedures. We have to go inside those and pull them apart.
Right.
And we do a very detailed job of that. Okay. So it will still take some time, but I believe we've made it much better than before.
Okay, great. Another was another sort of troubleshooting thing for us was we've also integrated it with TFS with Team Build, but we tried anyway to a certain degree. There are lots of different ways with our custom builds to kick off, as you covered the like a database administrator could say, I want to do this target database. Do you happen to have anything that is a little more maybe built in for Team Build? Is that something that's covered in the new feature set? Or would we still want to look to doing custom builds, executing commands?
No, I'm not sure I'm able to answer the question well. I mean, maybe we should take that up offline.
Okay, yeah, okay. So I'll do that. That was the most obscure. The last one I think was an easy one, if I can remember, which was, yes, since we are using that older tool, do you think we'll be able to, from our own current version, be able to upgrade with the model from that tool, or will we need to
yes,
reset?
you will. So the question is, can you upgrade? Indeed, we upgrade. So you can choose, and we'll install side by side with those tools on 2010, VS 2010, and you can choose to upgrade. If you want to open them in SSDT, you need to upgrade the projects.
But they will open.
But they will upgrade and they will open.
Great.
But then they will be open in these tools.
It's a one-way trip.
Yes,
You're not going back again.
That makes sense. Okay, thanks a lot.
Okay, thank you. Yes, go ahead.
During the model compare, when changes are identified, what's the underlying mechanism then for completing the changes to the production or the current view of the database? Is it still going to do table alters?
Yes, again, it's this, the schema compare is exactly the same engine is used when you publish or you deploy as schema compare. So basically we build those two models, the model of the database, the target, the model of the source, difference them. So, you know, whether it was your project or a database, it's the same outcome. And we produced this script, and there was an option to generate the script on schema compare. You can generate the script, and then you've got a file, you can look at it, you can change it, hand it off to a DBA.
Yeah.
Okay?
We're out of time, Bill, I'm afraid, so this will have to be the last one.
Last question, maybe. I think you are the last question.
Some of us work in the modeling tools, as Designer, ER Studio, some of those tools.
Yes.
And we sort of like working in those tools as a visual representation first, and then create the model.
Yes, yes.
We find it very difficult to work with this model because there's no way to sync the visual model up with the code. At the same time, this is very compelling from I'm writing my stored procedure, I'm getting the IntelliSense, I'm getting a lot of stuff out of it. Any thoughts about how to bridge those until you have a visual model?
Well, I was going to say, of course, the best bridge will be our own tools.
Yes.
So yeah, and I have to say that we're just starting out on that journey. So maybe it may be a little while before we're up to speed with something like an Owen-like product, which is a great product. They do very well in that space. I guess the database is if you make changes through the database, you could synchronize through the database.
So
but we're not offering, we're not opening an API over the model at this point. So there's not going to be a sort of third-party hooks into the model itself, at least not at this stage.
So how do you support two parts? First, obviously, you take your model, you build it to a database, then you do schema compare to bring it into your system, I presume, right?
Yes, or we have a direct import story as well, yeah.
How do you prevent changes being made in the model inside your system from then being wiped out as part of the schema compare, except lots of really, really detailed hard work?
Being knocked out by the schema compare. So schema compare, if you have so this is going to come down to a sort of life cycle strategy kind of approach here, and we just kind of off the cuff something. If you have a model, which is the model you're working on with our tools, and then you have a database that represents that, and then you have another database that represents the one being worked on by architects working with Irwin, say, then you can use schema compare to difference those two. And then schema compare gives you this very fine-grained, blow-by-blow account of what's different between them. And you can go through and you can say, yep, nope, yep, and you can take those and check them off and apply them.
Right.
Does that address the...
That's the very detailed work I was talking about.
Yeah.
I'm trying to avoid.
You're trying to get some sort of policy-driven kind of story? What's the sort of thing? Well, it's kind of interesting.
Avoid comparing stored procedures, avoid comparing...
Well, you can exclude things from that comparison. There are lots of options that let you decide what it is you want to compare. So you don't have to take...
automate those? Any way to automate that?
Not at the moment, no, I'm sorry. Again, it's the same answer in a sense.
Yeah.
Okay.
So yeah, thanks for the question.
Yeah, I'd love to maybe chat about that.
So
okay.
If anybody does have any other questions, please come see us on our stands. And if you don't get us by then, the email was on the deck. Please send us mail or contact us through the blogs. And thanks ever so much for turning out.